you all to the final revision edition. In this edition, we'll encounter miscellaneous questions, such as write the scientific term, explain what is the scientific expression, proof, units, and so many other things. Hopefully you will find them interesting and useful to you. So let's get started. What happens when? In front of you, we've got a circuit. Usually we use it to demonstrate, self-induction. The question is about what happens when the key shown in the circuit is opened. Okay, it's all easy for you. And we want you to justify your answer to account for your answer. So what happens when the key is opened? Yes, the lamp momentarily flashes because of the high forward EMF induced by self-induction. In the circuit in front of you, okay, what happens when the key is closed? First of all, when the key is open, the voltmeter across the battery reads V battery, so it is maximum right now. But the voltmeter across R2 reads 0. What happens? V1, okay, decreases when we close the switch, but V2 will got a value, so it will increase. So what happens when the switch is closed? Okay. With respect to the readings on the 2 voltmeters, V1 voltmeter across the battery decreases. Right now, when we close the circuit, it reads just terminal voltage. When the key was open, yes, it read V battery. And what about V2? It was reading 0, but right now it has got a value. So V1 decreases, but V2, yes, increases. What happens when a metastable helium atom collides with a ground state neon atom? This is a very important question. Yes, the excitation energy of the helium atom is transferred to the neon atom. And this way, a population inversion situation can be reached. And this makes the stimulated emission predominant. What happens when high energy photon, such as gamma or X-ray photon, collides with a free electron? The photon scatters. Scatters mean it changes its direction. The photon scatters, and it is called as the scattered photon. The scattered photon has longer wavelength, lower frequency, lower energy than the incident photon, because the incident photon loses part of its energy. It gives part of its energy to the electron. The energy lost by the incident photon is gained by the electron. What happens when an electron having very high kinetic energy collides with a target made of material having high atomic number? So we are talking about X-rays, and the bombarding electron have very high energy. So we expect to have the 2 spectra of X-rays. The 2 spectra of X-rays are produced. What happens when a white light means continuous spectrum, is passed through sodium vapor? This is very important. Dark lines appear because the vapor absorbs its characteristic wavelengths. What happens when X-rays, are passed through gases. When X-rays pass through gases, what happens? The gases are ionized. The gases are ionized. What happens? When X-rays pass through a crystalline material, X-rays diffract, so interference patterns are produced. These interference patterns reveal the structure of the crystalline material. Another type of questions: when does each of the following quantities equal 0? Okay, when does the torque acting on a coil carrying an electric current placed in a uniform magnetic field equal 0? This happens in the vertical position. The torque equals 0 in the vertical position, where the plane of the coil is perpendicular to the field. Okay. Torque is determined from the relation BIA and cosine theta. Theta in this particular case is equal to 90, cosine 90 equals 0. When does the magnetic flux at any point inside and along the axis of a current-carrying solenoid equals 0? Okay, when the solenoid is made of a doubly wound wire. When does the EMF induced in a wire moving in a uniform magnetic field equals 0? Of course, when the wire is moved parallel to the field. Instantaneous EMF induced in the wire is determined from the expression BLV sine theta. When moving parallel, theta is equal to 0, sine 0 equals 0. Okay. When does the force of a magnetic field on a current carrying wire equal 0? Yes, when the wire is placed parallel to the field. When the wire is placed parallel to the field. Okay. The force is determined from the expression BIL sine theta. Force is equal to 0 when theta is equal to 0. When placed parallel, sine 0 equals 0. When does the difference between EMF of a cell and its terminal voltage equals 0? It means it asks you when the EMF is equal to the terminal voltage. So there is no difference between them. Okay, thank you very much. When the circuit of the cell is open, that's to say the resistance across the terminals of the cell is infinite. No current passes through the cell. Or when the internal resistance of the cell is equal to 0. It is negligible. Okay. When does the average EMF induced in a coil that rotates in a magnetic field equal 0? Okay. When the coil completes one cycle. Also, when the coil completes half cycle from the horizontal position. When does the magnetic flux density at a midpoint between two wires, between two current carrying wires equals 0? At the midpoint. So it happens when the two wires carry equal currents in the same direction. When does the current in the primary coil of a transformer, in spite of its connection, in spite of the connection of the primary coil to an AC supply, the value of the current is equal to 0? Yes, this happens when the secondary coil of the transformer is unloaded. When the secondary circuit, the circuit of the secondary coil is open, actually a backward EMF is induced in the primary coil, which is nearly equal to the EMF of the supply. So no current passes in the primary, though it is connected to the mains. When does the electric conductivity of a pure silicon crystal equal 0? It happens at the absolute 0. At this particular temperature, all the bonds are assumed to be intact. Okay. When does the mass of a photon or the linear momentum of a photon, yes, equal 0? When it comes to rest, when the photon comes to rest. When does the output of an AND gate is equal to 0? When either all inputs are equal to 0. When does the kinetic energy of the electrons extracted from the surface of a metal by electromagnetic radiation equal 0? This happens when the frequency of the incident radiation equals the threshold frequency of the metal. Electrons are ejected but with 0 kinetic energy. We've got very important question now. An AC supply of variable frequency is connected each at a time to the following, items. It is connected to a pure inductor and pure capacitor and non-inductive ohmic resistance. Pure inductor, pure capacitor, non-inductive ohmic resistance. What happens to the maximum current that flows in each circuit when the frequency is doubled? When the frequency is doubled. Okay, we'll take it one by one. In case of the pure inductor, maximum current is determined from the expression I maximum equals V maximum over XL. Maximum EMF is NAB 2 pi F. XL, inductive reactance, equals 2 pi FL. So what happens? 2 pi F will be crossed out. Okay. So it is quite clear the maximum current in this case, in case of the pure inductor, yes, it is independent of the frequency. It doesn't depend on the frequency. Maximum current is independent of the frequency. So it has no effect. Talking about the second case, the case of the capacitor, maximum current is determined from V maximum over XC. Maximum voltage, it is NAB 2 pi F, NAB omega is equal to pi F. XC equals 1 over 2 pi FC. So it is quite clear that maximum current, yes, is equal to, or it will be proportional to square the frequency. Okay, it is proportional, directly proportional to, square the frequency. So when the frequency is doubled, maximum is made 4 times greater. So I maximum is made 4 times greater. It is quadrupled when the frequency is doubled. Talking about the last item, which is the non-inductive resistor. Once again, maximum current is determined from the expression V maximum over R. It is NAB 2 pi F over R. So maximum current is proportional to the frequency. Frequency is doubled, maximum current is doubled. Maximum current is doubled when the frequency is doubled. Okay, another type of question. Explain. The action of the diode resembles that of a switch. Okay, it's all easy for you. The diode has a small resistance when it is forward biased and very high resistance when it is reverse biased. That's why it resembles a switch. Explain. The resistor can be used as a binary device. Since a transistor circuit can have 2 states, off or on, it can be used as a binary device. By the way, a binary device, a binary system is a digital system based on only 2 digits, which are 0 and 1. Explain. At very low frequencies, the AC circuit that contains a capacitor is considered as an open circuit. Open circuit means no current almost flow. Okay. Since XC is equal to 1 over 2 pi FC, so XC is inversely proportional to the frequency. When the frequency is very small, XC is very large. A reactance is some sort of opposition, so the current, yes, vanishes. So the capacitive reactance increases when the frequency is decreased and almost no current flows in the circuit. Explain. The hot wire ammeter can measure both AC current and DC current. As a matter of fact, the function of the hot wire ammeter depends on thermal effect of the electric current. DC and AC have thermal effects. Okay? Both AC current and DC have thermal effects, so they can be used, yes, they can be measured by the hot wire ammeter. In RCL circuit, okay, circuits that contains, yes, inductor, capacitor, and ohmic resistor. The current and the voltage are in phase when the circuit is in resonance state. At resonance, what happens? Inductive reactance equals capacitive reactance. Voltage across the inductor is equal to the voltage across the capacitor. Total voltage is equal to the voltage across the ohmic resistor. The impedance is reduced and is equal to the ohmic resistor. Voltage and current are in phase, that's to say phase angle between them is equal to 0. Explain. At any given temperature, when a state of thermal equilibrium is reached, there is a fixed number of free electrons and positive holes in the pure semiconductor at that temperature. Okay, it's all easy for you. The number of broken bonds per second equals that mended bonds per second at any given temperature. This is a law, very important law, mass action law. Okay. Explain. The base in the transistor should be very thin and lightly doped. Yes, when it is very thin and lightly doped, yes, this minimizes the number of the free electrons that combine with the, yes, positive holes in the base. So once again, to minimize the number of the free electrons that combine with the holes in the base. Another type of questions, we've got a figure shown in front of you right now. The figure shows some possible transitions for the electron of a hydrogen atom. Your attention, please. Which transition gives the photon that lies in the infrared region? Okay, infrared region, it must be line C. Okay, because line A, the electron relaxes to the first. It is, yes, Lyman. And what about B? It is Balmer. So it must be line C. Which transition gives the photon with the highest energy? Highest energy is the first group, highest frequency. It is ultraviolet region. It is line A. Thank you very much. What is the name of the series that line B belongs to? It's all easy for you. It is Palmer series, the only visible one. We've got a problem relating to the same topic. A photon of wavelength 486.1 nanometer is emitted by the hydrogen atom. Calculate the photon, the energy of the photon. Okay, given that Planck's constant is equal to 6.6 times 10 to the power of negative 34, speed of light in space 3 times 10 to the power of 8. Then use the opposite table to determine the two levels between which the electron is transmitted. First of all, we need to calculate the energy of the photon. Energy of the photon is determined from the relation, yes, h nu, each frequency, and frequency equals c over lambda. So it is 6.6 times 10 power negative 34. C is the speed of light in space, 3 times 10 power 8, over wavelength, and it should be converted into meters, so it is multiplied to the, yes, to the power of negative 9 to convert it from nanometer into meter. We've managed to obtain the energy. It is 4.08 times 10 power negative 19 joule. And we could convert it into electron volt. Yes, it is divided by, thank you very much, 1.6 times 10 to the power of negative 19 to obtain the same energy but in electron volts. So energy of the photon equals 2.55 electron volt. So the transition must be from N to L. The two energy levels, the difference between them is equal to 2.5. It is energy level N and energy level L. Very important question. Graph A shows, graph A, in front of you we've got 4 graphs, graph A, B, C, D. Graph A shows how the current produced by a simple dynamo changes with the time of rotation of the coil of the dynamo from the vertical position. And other graphs show the current produced by the same dynamo, okay, but after certain modifications have been made or connecting the dynamo with another device. Okay, what modification has been made for the dynamo to produce the current represented by graph B? I believe it's all easy for you. The current right now is unidirectional, but it's still changing. So the two rings are replaced by a commutator. What device has been connected to the dynamo to produce the current represented by graph C? You'll notice that the amplitude is increased. So the current is increased. We did something to the current to increase it. So we must use a step up or a step down transformer. Step up will increase the voltage and decrease the current. So we used a step down transformer. We used a step down transformer. That's why the current is increased. Yes, it increased with the same frequency. What device has been connected to the dynamo to produce the current represented by graph D? It's all easy. It is half-wave rectification. So we used the diode, PN junction diode. We used PN junction diode. We've got a problem, a simple one. Use the circuit to find the reading on each voltmeter. The circuit contains an AC supply of effective value 100. XC, XL are equal. Each one of them is equal to 25. Ohmic resistance has got a value of 50 ohm. Okay, we want the reading on each voltmeter. Knowing that the effective value of the supply is 100 volt. We are in a state of resonance, so the impedance is equal to the ohmic resistance. It is equal to 50. Current is equal to the voltage, 100 over Z, which is 50, so it is 2 ampere. Voltage V1 across the ohmic resistor, it is current times the resistance, 2 times 50, 100. Voltage across the coil, V2, yes, it is VL, it is IXL, 2 times 25, it is 50. Voltage V3 across XC, it is 2 times 250, it is 50. Your attention. Voltage denoted by V4, it is the difference between V2 and V3, it is 0. Okay. What is the gate which has two inputs and the output is high only if each of its inputs is high? Okay, it is AND. What is the logic gate which has a low output voltage if only one of its inputs is low? Also, it is AND gate. Choose. When the EMF induced in the dynamo coil equals half the maximum, the plane of the coil makes an angle. It's quite clear now. Is it 30, 60, 45, or 90? Right now it is 60. The ratio between the average value of an AC voltage through a quarter of a cycle in the dynamo and through a half cycle, is it 0.707, 1, 2, or pi over 2? Actually, the average during a quarter of a cycle is the same as the average during half cycle. It is 1 to 1. Okay, so the ratio is 1. The transmitted electric signal in the cathode ray tube controls the potential of filament, grid, anode, cathode. Of course, it controls the potential of the grid. And now, compare between AND gate and OR gate with respect to the way the transistor is used to serve as each one of them. This is very important comparison. For the transistor to serve, to act as an AND gate, it should have 2 or more emitters. And for the transistor to serve as an OR gate, 2 or more transistors are connected in parallel to each other. Compare between DC ammeter and DC motor. Ammeter and motor with respect to the direction of the current flowing in the coil of each one of them. Actually, the direction of the current in the motor is reversed each half cycle. Direction of the current in the coil of the motor is reversed each half cycle. But the current flows in the same direction in the coil of the ammeter. Compare between hot wire ammeter and moving coil galvanometer with respect to the uniformity of the scale of each one of them. The scale of the hot wire ammeter is not uniform, but that of the galvanometer is uniform. Okay, scale of the hot wire ammeter depends on square the current, but in the galvanometer it depends on the measured current. And this way we've come to the end of the final revision edition. Before I go, I just want to say 2 words. You are a little bit worried and tense. This is quite normal, but don't let your stress control you. Limit your stress. All you have to do is to, yes, trust yourself, trust your abilities, expect the best and go to get it. Best wishes from the director, Mr. Hisham Yunus, and from me, Usama Rashidi. Bye-bye.